After the Second World War, Britain found itself with an enormous surplus of aviation expertise, skilled engineers, advanced materials, and manufacturing techniques originally developed for building aircraft. Rather than let that knowledge go to waste, several British manufacturers channeled it directly into car production, creating vehicles that borrowed genuine aerospace thinking. The results were sometimes brilliant, sometimes eccentric, but always fascinating. Let's count down 10 British cars that were genuinely built using aircraft technology and engineering expertise. Number 10. Armstrong Siddeley. Armstrong Siddeley operated as both a luxury car manufacturer and a genuine aircraft engine producer throughout the first half of the 20th century, giving it a uniquely direct relationship between its two very different product lines. Engineers move between aircraft engine development and automobile production, sharing metallurgical knowledge and precision manufacturing techniques across both divisions. This dual expertise gave Armstrong Siddeley's cars a level of engineering refinement that purely automotive manufacturers often struggle to match, reflecting genuine aerospace-grade attention to detail in components most drivers never even noticed. Number 9. The Bristol 400. Bristol Cars emerged directly from the Bristol Aeroplane Company, one of Britain's most important aviation manufacturers, and the Bristol 400 was the company's very first production car. Its design borrowed heavily from pre-war styling, but its manufacturing benefited enormously from genuine aviation industry techniques that gave it noticeably higher performance than its contemporaries. This direct lineage from aircraft manufacturing meant the 400 was built with a level of structural precision and attention to aerodynamic efficiency that few purely automotive competitors could replicate at the time. Number 8. The Bristol 401. Following directly on from the 400, the Bristol 401 introduced genuinely streamlined bodywork that reflected serious aerodynamic thinking borrowed straight from aircraft design principles. Every curve was shaped with airflow efficiency in mind, rather than styling trends alone. This aerodynamic focus gave the 401 noticeably better performance and stability at speed compared to more conventionally styled rivals, a direct benefit of Bristol's engineers applying genuine aviation aerodynamic principles to automotive bodywork design. Number 7. The Bristol 402. Bristol's convertible offering, the 402, carried forward the same aerodynamic philosophy as its closed-roof sibling, adapting aircraft-derived streamlining principles to an open-top design without sacrificing the structural rigidity that aviation engineering demanded. Achieving this balance required genuine expertise in stress distribution and structural design, knowledge that Bristol's engineers had developed through years of aircraft fuselage construction before ever turning their attention to automobiles. Number 6. The Bristol 450. Bristol's racing ambitions produced the 450, a car that achieved remarkable success at Le Mans, taking first, second, and third place finishes in both the 1954 and 1955 endurance races. This success reflected genuine aerodynamic and structural engineering excellence borrowed directly from Bristol's aviation background. Following the tragic 1955 Le Mans disaster, Bristol's racing department closed entirely, but the 450's achievements remain a genuine testament to what aircraft-derived engineering could accomplish when applied seriously to motorsport competition. Number 5. The Marcos 1800 GT. Aerodynamicist Frank Costin, who previously worked directly for the de Havilland Aircraft Company, brought genuine aviation construction philosophy to Marcos when he helped develop the 1800 GT alongside founder Jem Marsh. Costin pioneered a plywood monocoque chassis, a construction method drawing directly from aircraft fuselage engineering principles he developed during his aviation career. This unusual wooden structure gave the 1800 GT exceptional torsional stiffness combined with remarkably low weight, proving that genuine aircraft construction thinking could translate directly into automotive engineering with real, measurable performance benefits. Number 4. The Lotus Elite. Frank Costin's influence extended beyond Marcos into his earlier work with Lotus, where his aviation background directly shaped the aerodynamic thinking behind the elite's genuinely advanced fiberglass monocoque construction. Every surface was considered for airflow efficiency, reflecting the same principles Costin had applied to aircraft design. This aviation-influenced approach gave the elite exceptional efficiency and handling for its modest engine size, proving that aerospace aerodynamic thinking could deliver genuine competitive advantages even in a relatively affordable production sports car. Number 3. The Rover Jet 1. Rover's engineers drew directly from aviation gas turbine technology when developing the Jet 1 in 1950, creating the world's first car powered entirely by a genuine gas turbine engine. Technology borrowed almost entirely from aircraft propulsion systems of the era. While the Jet 1 never reached mainstream production, its very existence demonstrated just how directly British car manufacturers were willing to experiment with technology lifted straight from aviation, years before turbine power in road cars became a serious consideration anywhere else in the world. Number 2. The Rover BRM. Building directly on the Jet 1's turbine experiments, Rover partnered with racing team BRM to develop a genuinely competitive gas turbine racing car, entering it in international endurance events including Le Mans. This project pushed aviation-derived turbine technology considerably further than Rover's original road-going experiment. The Rover BRM's participation in serious international motorsport competition proved that aircraft propulsion technology could genuinely compete, at least experimentally, against conventional piston engines in demanding racing conditions, even if the concept never achieved widespread automotive adoption afterward. Number 1. Bristol Cars. At the top of our list sits the manufacturer whose entire existence represents the single most direct link between British aviation and automotive engineering. Bristol Cars was established directly by the Bristol Aeroplane Company, one of the most historically significant aircraft manufacturers in British history, responsible for everything from early biplanes to sophisticated aluminium monocoque aircraft structures, decades before most manufacturers considered similar techniques for automobiles. This wasn't simply a case of borrowed inspiration. Bristol's cars were engineered by teams who had spent their careers building actual aircraft, bringing genuine aerospace-grade manufacturing standards, aerodynamic testing methods, and structural engineering philosophy directly into automotive production. Every Bristol car benefited from decades of accumulated aviation expertise, reflected in everything from panel fit and finish to genuine aerodynamic efficiency that few purely automotive manufacturers could match using conventional car industry thinking alone. Bristol's small, dedicated customer base often specifically valued this aviation heritage, understanding that they weren't simply buying a car built by a car company, but a vehicle engineered by people who had spent their careers ensuring aircraft stayed safely in the sky. What connects every manufacturer on this list isn't simply shared engineers or borrowed components. It's a genuine transfer of knowledge between two of the most demanding engineering disciplines imaginable, aviation and automotive design, each pushing the other toward genuine innovation. British aircraft manufacturers didn't simply diversify into cars for financial convenience after the war. They brought real expertise, precision, and aerodynamic thinking that fundamentally shaped some of the most fascinating and technically interesting cars Britain ever produced.